Here we go. Properties of exponents. Number 1, evaluate 5 to the negative 4 power. Write your answer as a fraction in simplest form. That would be 1 over 5 to the 4th power, which if it wants that as an answer, it is 1 over 625. If you don't know why, negative exponents basically will flip into either the denominator or the numerator. For example, I don't know if we have any coming up where we have a negative exponent in the denominator, but let's pretend that it had been right here, like right there. If it had been, then the answer would look like this or this, right? But either way, these are our answers without that little negative sign. Same thing here. This is going to flip down. So on bottom, we have 5 to the 1st power. And we don't write that 1st power because it's kind of invisible. It's understood. Now, this piece right here is a little annoying because you have to almost think like a calculator. And what I mean by that is that this exponent right here is only applying to this number right here, and that this negative is floating out in front. So what's going to happen is that this green part is 1, and this negative is still floating out there. Now this part it's got to be 1 because it can't just become 0. So that's 1. So our answer is ultimately negative 1/5. You can put the negative with the 1 or with the 5. I don't think it matters. Number 3, this should be real fast, real simple. X to the negative 7 power becomes that. Simplify this thing. So I guess back up here when I say think like a calculator, I say that because if you were to type this into a calculator, if you were to type negative 9, but even negative 9 squared, it would do this, negative 81, because it would see negative 9 times 9, okay? I guess it makes a little bit more sense when we see things like this, because we're thinking, okay, well, this C part, this negative 8 is really only affecting the C, so we're going to have the 15 on top, the C slides down to the bottom, and then this d to the 0 power is just 1. So we don't even need to write that part. So let's erase it then, shall we? And we just say 15 over c to the 8th power. Number 5, this is one piece. This is another piece. And this is the final piece. So, oh yeah, we do have one where there's a negative exponent in the denominator. So this is going to go up, the green part is going to go up, the purple part's going to come down, and the red part is just 1. So our final answer is b to the 7th over 4 to the 3rd power. What does it say? Using positive exponents. Let's see. I believe that it might actually ask you to write that out. So it's b to the 7th over 64 like that. Number 6, we have, and now I'm going to, I guess I can still do this is one piece, this is one piece, this is one piece, this is one piece. Oh, you know what? I need to put that part with that. And this is one piece. Okay, so if we're doing that, then this 13 just stays 13, okay? That x to the 5th jumps down. That y to the 0 is 1, so we can do a times 1 there if you like. This 5 to the negative 3 jumps up, so it becomes like that. And then this yellow piece is going to jump up times z to the 10th. Okay, so let's see. If you were to do 5 times 5 times 5, what is that? 125? And 125, let me pull up my calculator, 125 times 13, 125 times 13 is 1625. So our final answer is 1625, z to the 10th over x to the 5th. That was fun. now we have, so this is where, again, we're always kind of thinking like a calculator, but check this out. There's parentheses, and this squared is squaring the whole set of parentheses, so it would be like this, right? And we've actually just got 2 of these. So really the idea is this is -9 to the 4th power, and you could really just grab a calculator and do 9 to the 4th power, which is 6,561. And if you're wondering about, like, well, wait a second, so there's a lot of negatives here, but there is an even amount of them. And what does that mean? Well, if you have an even amount, that it means it ends in 0. You have either 0, 2, 4, 6, or 8 of something. And then obviously you know that, you could put a 1 in front of that, and now all those are even, yada, yada, yada. So if you have even amounts of negatives, you're going to get a positive. So that's why this is positive, and we're done. Number 8, you have a power being raised to a power. And so what that does is S is now -5 times 3, which that's -15. So this is going to be 1 over S to the 15th. That's it. Number 9, simplify. So we can do this piece and then deal with him. It's really kind of up to you on how you want to deal with that. I don't mind dealing with this, and 5 minus 4 is 1, so that just becomes x, and then there's another x, so the answer is x squared. Like I said, it really just depends on how you want to deal with that to how you get to the end. If you wanted to go ahead and multiply these two, you would have gotten x to the 6th over x to the 4th, and guess what? That's x squared. Next, we are modeling in real life a seed from an orchid plant. Seed from an orchid has a mass of 10 to the -6 grams. The mass of a seed from a double coconut palm is 10 to the 10th times the mass of the seed from the orchid. I gotta lie, I already kind of read this one, and so I knew that was going to kind of overlap. And it wants to know, what is the mass of the seed? Here, I'll do this in a different color. What is the mass of the seed from the double coconut plant in kilograms? So what I'm going to do is I'm going to take the orchid, and what I'm going to do is literally what this says, that the coconut is, so cocoa is 10 to the 10th times the orchid. And so I guess I probably should have done that in blue, but whatever. Cocoa times 10 to the 10th. What we end up getting is that the cocoa equals 10 to the 4th. Okay, so now we want to know how many kilograms that is, and they tell us that a kilogram is 10 to the 3rd. So if this is grams, what we can do is we can divide this by 10 to the 3rd grams, and what that's going to do is give us our kilograms. So 4 minus 3 is 10. We get 10 kilograms. So, by the way, I said that I'd already read this one before, because at first what I tried to do was get a little cutesy and show you okay, 10 to the -6th power would look like this, and I went 1, 2, 3, 4, 5, 6, and yada yada yada. It was the same, but it took me 4 times, 5 times as long to do this problem, and so I was like, you know what? Let me see if I can do it this way, and it turned out to be, faster. Yeah, maybe I knew the answer, but I think technically so do you doing this one. Anyway, next. Simplify -5z. All of that is raised to the 3rd power. So we're going to get -5 cubed, z cubed. So 5 cubed, so if we just did 5 times 5 times 5, that's 125. But there's a negative out front, so it'll be -125 z to the 3rd. Simplify this. This whole thing is being squared. So negative t times negative t is t squared, and 3 times 3 is 9. This is t squared over 9. Now we've got this whole thing is being raised to the negative 2 power. One thing I like to do with that is remind myself of PEMDAS. Funny how this is the first time I'm mentioning PEMDAS in this whole thing, considering exponents and parentheses are really like all over the place on this, right? So you're supposed to deal with the parentheses first, but let me ask you a question. What about this inside of parentheses can you do? Nothing. And same thing, can you do anything with that parenthesis right there? No. But you have the option here of doing a couple different things with this exponent, this purple one. I will show you what I don't like to do. And you know what, let me show you what I like to do first, and then what I don't like to do. What I like to do first is this. That negative exponent, I can essentially flip the whole inner contents. Don't change anything, but change the exponent. I like to do that. And if you're like, how is that possible? Well, let us see. What we could do is distribute this exponent to that. And what we would get would be negative w to the 6th power over, and then it would also be that 6 to the, oh, you know what I forgot to do? I forgot to distribute the negative part of it. So this would be negative 6. So let's do that negative right there. And it would be 6 to the negative 2 power. Well, guess what? Negative exponent flips up. So we get 6 squared on top. Negative exponent here flips down. So we would get w to the 6th on bottom. And that negative is still there. We still have the whole contents of this as negative. So check this out. This yellow part right here is technically the same as this. I just haven't distributed, or I haven't dealt with the squared part yet. So either way, we get 6 squared, which is 36. Either way, on bottom, we get w to the 6th, and it's negative. The end. For this next one, unless you just know the formula for volume of a square pyramid, you're going to be a little stuck. So I Googled it and put an image, I did a Google image search, because that works with this app. And what's going on here, just so you know, is the volume is going to be 1/3 of, now I don't know how your geometry teacher will teach you this, but I call big B. I call that big B. And my idea of the big B is like its butt. It's big butt that it rests on, and it's the base. I know that seems a little goofy, but I try to be a little goofy to help you remember things, right? Big B will always be the butt, the base, because every now and then you have a little b, and it's not the same thing, and so I just don't want you to ever get that confused. So great. It's 1/3 times big B times the height, and that's basically what we have here. Oh, and also if you're like, okay, well, big B, well, what the heck are you trying to say? Well, big B, so see how it says A of big B right here? Well, the area of big B is side squared because it's a square. So the area of a square is just literally side times side, or side squared, right? You could technically say it's length times width, and it would work for a rectangular pyramid, I believe. Anyway, so it says, which of the expressions represent the volume of the square pyramid, where S is the side length of the base. So here we go, side length is S. But they're also telling us it would appear that the side length could also be 3h. And I'm not even done reading. S is the side length of the base, and h is the height. So basically, they want you to go over here and be like, hey, plug this info into this, see what you can produce, see are there different ways you could come up with this. So how about this? 1/3, well, it's going to be s squared h. Do we have that as an answer choice? let's see. No, not really. So they're getting funkier with it. So this is right, but they don't like it. So let's like I said, let's get funkier with it. Let's say that this S and 3H are the same thing. So what if we plugged this in here? We'd get 1/3 times 3H squared H. Well, that would be 1/3 times 9 times H squared times H. So that would be 9/3 times H cubed, which if we simplify that, we get 3H cubed. And yeah, we do have one of those. So, okay. Is there another way we can say that? Perhaps. In fact, I think I see one. What if... Well, so I was thinking, does this one match that? And the answer is no. Because... So I guess let's just get rid of that one. Because... Let me erase it so I can talk about it real fast. See how this one is, 3 on top? Well, this one, the 3 would be on bottom. So again, we don't really like that one. So, bye-bye. H cubed, I mean, I don't like this one, right? Because that's clearly not 3H cubed. Oh, okay. This one is good. Kind of stupid, but it's good. Because, listen, if you were to take this and flip it down, it would have to be 3 to the negative 1 power. And if you were to take this and flip it down, it would be H to the negative 3rd power. So that's good. There is one more answer, and notice that they both... Well, so here are our choices, and there's one or more of them that's correct. Both of those choices basically say, all right, well, I think they take the height and kind of switch it for S. So let's do that. A side length is normally, is not normally. We know that a side length is 3H, so we could divide by 3 on each side and get that the height is really actually S over 3. And so if we were to take this... Let me kind of switch colors so you can see a little bit more clearly what I'm trying to do. If we were to take this and plug it in here, would that give us what we're looking for? So let's try that. So here, I'll do the green. 3 times S over 3, that whole thing cubed. Because look, that was height cubed. So here we have the height is really that, and we have that. So let's do that. We're going to get 3 times S cubed over 3 cubed. And what's going to happen is one of these 3's is going to cancel one of those 3's, leaving us with S cubed over 9, because 3 squared is 9. Yay, we figured it out. It's this one. So here we go. Wrapping it up on this one. It's this one, and this one, but not that one. Okay, fun. Simplify this madness. Okay, will do. So, what I'm going to do first is get rid of anything to the 0 power, because that's silly. And then, I mentioned that we haven't talked a lot about PEMDAS. I'm going to go ahead and do some PEMDAS personally just because I want to get rid of my negative exponents. So I'm going to go inside and do the parentheses first. And basically, I'm going to encourage you to write this out. So 3n squared, because those two are going to be the same. 4 on bottom. And then now that's going to change, that's going to change. I suppose we could have really not taken our time with this, I suppose we could have subtracted them, because it would have been -5 minus -2, and we would have gotten -3. But I'm still, like I said, I'm just going to do this. So that is this first piece like that, okay? And yes, we could go ahead and simplify this and be like, that's gone, and this is now 3. totally doable. In fact, we'll just leave it that way because we've done that. So essentially now I'm going to distribute that power and get 3 squared n to the 4th over, and now I got to make sure and write the other one, that one there, and that one there. 4 squared and m to the 6, because 3 times 2 is 6. Okay, we haven't messed with this part at all, and we could go ahead and simplify it, so why don't we do that? M is not going to change, but these n's can simplify a little tiny bit. We'll get n to the 3rd over 9, and this whole thing is being squared. So just like the other one, that's going to be m squared n to the 6th and 9 squared. Okay, now we are multiplying all this together, okay? And basically, I'm just going to go straight. I could go straight across. I could cancel diagonally if I wanted to. For example, I could cancel this and make that 4, okay? This right here, 9 squared is really 3 to the 4th, right? Because 9 is 3 times 3, right? Or 3 squared. So, again, the reason I'm doing that is because I could cancel like this, switch colors here. I could say, hey, that's completely gone, leaving me with 3 squared on the bottom. So I'm just going to write this. 3 squared is 9, right? Okay. Let's write what we have left. We have n to the 4th times n to the 6th is n to the 10th over 4 squared times 9. Well, 4 squared is 16. 16 times 9. Can I do that in my head? I don't know if I feel like it. 54. Hang on. It's 90 plus 54 is 144. Yeah, I could do that in my head. Okay. N to the 10th over 144. That's what it was. Was there a faster way of doing this? Yeah, probably. There was probably a more optimized way. Oh, I actually wrote on the screen. You couldn't see it. There's probably a more optimized way of doing this. I never promised I would be the most optimized person to show you how to do these, but it's like a little puzzle, and you just got to make sure and move all the pieces, okay? 16. Let's see. This looks funky and looks like it's going to be trouble, but it's just one number times another number times another number times another number. So what we're going to do is I'm just going to slap them all in like this. And then what we're going to do is these two can just be multiplied together. So 6 times 8 is 48, like that. And then, let's see, 10 to the 3rd. Let me change colors. I'm not writing because I'm not doing colors. -3 and 9, well, that's 10 to the 6th. Now, there's one little silly thing about this that deals with scientific notation. When it comes to scientific notation, you don't leave the decimal here, you move it here. So it would actually be 4.88 times 10 to the, let's see, we moved it to the left. So we would want to move it back to the original, oh my gosh, brain fart, 10 to the 7th then? Because, yeah, that's the idea. Because what this is going to do is move the decimal place 6 places that direction. And since we moved it here, it would now have to move 7 places. So boom, this is your scientific notation answer. Yay. In standard form, I'm just assuming it means 488 and then 5 zeros. 1, 2, 3, 4, 5. How do I know it's 5? Because 1, 2, and that would mean there's 5 left, right? So 48.8 million. That would be your standard form answer. So if you need me to, 4.88 times 10 to the 7th. There you go. Both of those answers. There you go. The human body produces about 4.8 times 10 to the 6 red blood cells in 4 times 10 to the negative 2 minutes. Wow, okay. How many red blood cells does the body produce each minute? So one thing that I'm going to do here is to just write the units that are happening here. Is it's like red blood cells per minute, okay? And then the reason I'm doing that is because now I have red blood cells per minute. Like that, okay? And what I can do is, actually, this is a lot simpler than it initially first seems. What we can do is literally these two can divide each other. 4.8 divided by 4 is 1.2. That's not that bad. And then 10 to the 6 divided by 10 to the negative 2, you subtract those, so you would get 10 to the 8th. That is your scientific notation answer. Just boom, it's done. And then the standard form answer is move that one place and then give me 7 zeros. So 1, 2, 1, 2, 3, 4, 5, 6, 7. 120 million per minute. That's crazy if that's true. Crazy, I tell you. Last one, without evaluating, rewrite that as a single power with base 3. You got it. This guy is already done. He's base 3. This guy, well, 3 squared equals 9. And 3 cubed equals 27. So, what I'm getting at here is this is really 3 cubed to the 9th power. And hey, check it out. We did that right there. This is 3 squared to the 12th power. So let me rewrite what I just said, basically. We have 3 to the 10th times 3 to the 3rd to the 9th, all over 3 squared to the 12th. And what we can do is if you have a power raised to a power, you multiply the powers. So we have 3 to the 10th times 3 to the 27th. Yikes. And then right here we have 2 times 12, which is 3 to the 24th, right? When you are multiplying and have the same base, you add the exponents. So we would get 3 to the 37th over 3 to the 24th. And now we're just going to subtract 37 minus 24 is 3 to the 17th power, right? No. How about 13th? Yep, that sounds way better. 3 to the 13th, 3 to the 13th power. Last but not least, rewrite as a power of a product. It's a power, oh, okay. So notice there's cubed and cubed. Basically, they will need you to make that into a cube. So there's only one cube, one number small enough to make that happen. It's 2 cubed. We have that, and so they're saying rewrite this. So here, we rewrote this as this, but this isn't done. We're now going to do 2ab, all of it, cubed. There's your answer. So, some of those a little tricky, some of those a little less tricky. Let me know what questions you still have. See ya.